Okay, so we are at part B for section 1, chapter 7. Let's do one more of the scenarios where we have our integrating with respect to x, right? So we have these vertical rectangles. And then I will show you the scenario where that you will run into where you might be integrating with respect to y. So, okay, so the problem that we're looking at right now is for us to find the area between the following two curves. So right away, I'm noticing that I don't have my bounds specified. So that tells me I'm going to have to find the points of intersection. So I'm going to set my two functions equal to each other. And now what I'm going to do at this point is just set all of this equal to 0. So I'm going to bring this negative x squared over here. I'm going to bring this 2x over here. When I do, I would have, let's see here, I would have 3x cubed. I believe, so if I have negative x squared, if I add an x squared, so those would cancel out. And if I have negative 10x and I subtract 2x, I would have minus 12x is equal to 0. All right, so at this stage, let's go ahead and see if we can factor out. So in this case, I can factor out a 3x, leaving me with an, what do we got? An x squared minus 4. And I can go ahead and factor that a little bit more. That's just going to be x minus 2, x plus 2 equals 0. Okay. So to find the points of intersection, I'm going to need to know what value of x would make this factor equal 0, what value of x would make this one, what value of x would make this one. So obviously for the first factor, if x is equal to 0, then the whole left side equals 0. For the second factor, if x is equal to 2, the whole left side equals 0. And if likewise, if x is equal to negative 2. So I have 3 points of intersection. All right, so x is equal to negative 2, 0, 2. I'm just writing them in order of from least to greatest here. Okay, so the question is f of x above g of x from negative 2 all the way to positive 2? Well, let's kind of take a look at the geometry here. And so what you're noticing is that from negative 2 to 0, right? From negative 2 to 0, let's see if we can, the f curve is above the g curve. However, from 0 to 2, the g curve is above the f curve. So do you see how I'm going to need two separate integrals? If I want to find the area, I'm going to have to find area. Let's start with the area under here. And in that case, it's going to be f of x minus g of x. But I also need to find the area between the two curves from 0 to 2. And that's going to be g of x minus f of x. So you kind of see the dilemma that we can run into. So let's go ahead and set up this integral. So the area is going to be, let's start from negative 2 to 0. And that's going to be f of x minus g of x. 3x cubed minus x squared minus 10x minus g of x. Right? So the first interval is f minus g. All right, so that right there will give me this area. But I'm also going to have to, and so I have enough room. No, let's see if I can do a better job than that. Goodness gracious. Why don't you entertain yourself for just a second? So what I'm going to do is paste that so I can make it a little bit smaller. Now let's go ahead and add. So again, so the first integral just gives me this area. The plus, I need to figure out this area as well. So plus the integral, and now we're starting at 0 and we're proceeding to positive 2. Only this time, since g is above f, it's going to be negative x squared plus 2x minus 3x cubed minus x squared minus 10x. Okay, again, this is g of x minus f of x. So two integrals, the sum of two different integrals. So let's go ahead and combine like terms here. Let's combine like terms here. Let's see what that looks like. So from -2 to 0, if I combine like terms, I would be left with 3x cubed minus 12x. Now we're going from 0 to 2. Again, if I combine like terms, I would have negative 3x cubed plus 12x. Okay, so at this stage, I'm gonna, this is easy to integrate. Both of these are easy to integrate. What you would get is, after you integrate, you would have, I'm just gonna jump to the solution portion. So this would be negative 12 minus 24 plus, over here would be negative 12 plus 24. So the result would, let me make sure I'm doing that correctly. So I would have something tells me I did some, let me make sure I did my arithmetic correctly. Did I lose my section? Let's try that again. So let's go ahead. So if I integrate, this would be 3x to the 4th over 4 minus 6x squared plus, so from -2 to 0, plus negative 3x to the 4th over 4 plus 6x squared from 0 to 2. And yes, that is correct. What I had is correct. So that would be 12 minus 24 plus negative 12 plus 24, which when we combine, we get 24. Okay, so that's one of the worst case scenarios where you have to find the area between two curves, and your curves change, and so one, on one interval it's one function is above the other, and then another interval it's reversed. The last major topic, the major concept that we have to go over is when you're trying to find, again, you're trying to find the area between a curve, but take a look at the way your functions are written. So notice that in example 5, your equation is defined in terms of y. Right? See how it's solved for x? See how it's solved for x? So in this scenario, you're not looking vertically, you're looking left to right. So in fact, if you want to find the area between these two curves, we'll, instead of saying top minus bottom, we'll say right curve minus left. So we're going to take this curve minus this curve, right? So, and this, let's go ahead, we got to start with our points, we have to get back to our points of intersection, but let's go ahead and take note that g of y is the right curve, rightmost curve, and f of y is the left curve. So g of y is 3 minus y squared, and f of y is y plus 1. Okay. So let's go ahead and tackle these points of intersection. So just like before, we're going to set this equal to 0 and factor. So this is going to be negative y squared minus y. And if we subtract 1, we're going to have plus 2 equals 0. So if we factor this, we find that our points of intersection occur when y is equal to negative 2 and 1. All right, good. So let's go ahead and set up our integral to find the area. And we're going to be going from negative 2 to 1. All right. So remember, this time it's g, it's right minus left. So that's going to be 3 minus y squared minus y plus 1. And last thing is we are integrating with respect to y. Okay, so combine like terms, and we have negative y squared minus y plus 2. That's an easy integral. It's just going to be negative y cubed over 3 minus y squared over 2 plus 2y from negative 2 to 1. So back substituting f of b minus f of a, what do we get? We get 9/2. Interesting. So notice that if you wanted to, you could solve this equation for y so that you could do top minus bottom. You could solve this equation for y, only you would have a square root here, right? So plus or minus. So what I've seen students and you'll see this will become more apparent when we get into volume and just in the next section, but for some reason many students want to integrate only with respect to x. They only want to look up and down, not left to right. And that's doable, except, for example, if you were to solve these for y, this would be a much more involving problem. You would have, you would actually need the sum of two different integrals to do it. So just, again, don't develop habits yet. You just want to be fluid enough to be able to integrate with respect to x or integrate with respect to y, and just be willing to change them if one integration is easier than the other. Okay? You literally, seriously, the fact that you have to solve this for y should not be your main concern in a problem. Okay? Your main concern is how hard is the integral, not what is the algebra I need to do to get there. But nevertheless, that will take us to the end of 7.1, and I will see you in the next video.